One method of elemental analysis is called combustion train analysis. And in this method, you burn, say, a carbon-based fuel, and then you separate the products, water and carbon dioxide, to determine the amount of hydrogen in the fuel and the amount of carbon in the fuel. If there's also oxygen on the fuel, that can be subtracted from the total after you've determined the amount of hydrogen and carbon. So this is a picture of a schematic diagram, I should say, of a carbon train analyzer, where you can see oxygen is flowing through. There's a furnace where you burn the hydrocarbon, and then the water and the carbon dioxide come out and are trapped in different compartments. Let's take an example. Let's take a look at an example of a problem, and using combustion train analysis, determine the mass percent of each element in glucose. Here we have a 0.104 gram sample of pure glucose. It was burned in a hydrocarbon combustion train to produce 0.1486 grams of carbon dioxide and 0.0609 grams of water. It is known that glucose contains only carbon, hydrogen, and oxygen. Determine the mass percent of each element in glucose from this data. Okay, so what we need to do first of all is figure out what mass of carbon is in 0.1486 grams of carbon dioxide. All of that carbon would have come from this original sample. That will tell us the mass of carbon in the sample. We have to figure out what mass of hydrogen is in 0.0609 grams of water. And we do that by taking the amount of, first of all, carbon dioxide that we have, 0.1486 grams of carbon dioxide, and multiplying that by the mass percent, or the fraction of carbon in carbon dioxide. And so that's just the part of carbon over carbon dioxide. So if we have 0.1486 grams of carbon dioxide, we can multiply it by the parts of carbon, which would be in 1 mole of carbon dioxide, we would have 12.01 grams of carbon and 44.01 grams of carbon dioxide. And that is going to cancel the grams of carbon dioxide and give us the amount of carbon, grams of carbon, that must have come from this original sample in the carbon dioxide, and that's 0.04055 grams of carbon. Do the same thing for the water. We had 0.0609 grams of water. All right, trapped from that carbon train analysis. And so for every 18.02 grams of water, we have 2.016 grams of hydrogen in it. So that's the mass percent of hydrogen in the compound water. And that gives us 0.00681 grams of hydrogen. So now we know how much carbon was in the original sample and how much hydrogen was in the original sample. The question is then how much oxygen was in the original sample. Well, you take the original amount of sample, which was 0.104 grams total of your sample, and subtract from it the sum of the carbon in the sample, 0.04055 grams, plus the sum of the hydrogen, 0.00681 grams. And that is going to equal the amount of oxygen in the sample, which is 0.0540 grams of oxygen. So now we know how much oxygen we had in the sample, how much hydrogen we had in the sample, and how much carbon we had in that original sample. We can determine the mass percent of each of those in the sample by taking the amount of carbon and dividing it by the total amount of sample. So the percentage of carbon in glucose is going to equal 0.05055 grams of carbon divided by the total mass of the sample, which was 0.1014 grams of the sample, times 100%, and that's going to equal 39.99% carbon. Okay, do the same thing for the hydrogen. The percent of hydrogen in the sample is 0.00681 grams of hydrogen divided by the total sample, 0.1014 grams total sample, times 100%, and that equals 6.72% hydrogen. Do the same thing for the oxygen. We determine the amount of oxygen in the sample to be 0.0540 grams of oxygen divided by the total sample, 14 grams times 100%, and that equals 53.2% oxygen. Now we have the percentage of each element in the compound glucose. From this information, we can determine the empirical formula in the next video.